Here, let us discuss about Navy Bayes classifier. Navy Bayes is a supervised machine learning algorithm which is based on Bayes' theorem and that is used to solve classification problems by following a probabilistic approach. So this is mainly it is based on the idea that the predictor variables in machine learning model they are independent of each other, and the meaning that the outcome of model depends on set of independent variables that have nothing to do with each other. So we can say that simply this classifier is based on Bayes' theorem and it is mainly used to solve classification problems. So why it is called as Navy Bayes means in real world problems, usually predictor variables they aren't always independent of each other. So there are always some correlations between them. Since Navy Bayes considers each predictor variable to be independent of any other variable, it is called as Navy. So here it assumes that presence or absence of a particular feature, it is unrelated to other features. So it considers all predictor variables to be independent of other variables. So it is called as Navy. For example, if you take a fruit, a banana, so classifier will see that the fruit is yellow color and it is having some oblong shape, long and tapered. So all these features, they actually contribute independently for predicting that the given fruit is banana. And these features, they are not dependent on each other. So all these features are independently contributing the probability that the given fruit is banana. And this Navy Bayes model, it is easy to build and it is especially useful for very large data sets. So the principle behind this Navy Bayes is Bayes theorem, which is also known as Bayes rule. So Bayes theorem, it is used to calculate the conditional probability, which is nothing but the probability of occurring of an event, the probability of an event occurring based on the information about the events in the past. So it will take the events it will take the information about the events which are occurred in on the past, and it will calculate the probability of event. So Bayes theorem is usually represented as, so here if you take this equation, this P of C given X, it is nothing but conditional probability of event C occurring given event X. What is this? Conditional probability of event event C occurring given event X. And this P of C is probability of event C occurring. And this P of X is probability of event X occurring. And this P of X given C is conditional probability of event X occurring given event A. So here A is known as a proposition. So here C is known as proposition and this is proposition. Whereas X is known as evidence. And coming to P of C, that is the prior probability of the proposition. Whereas P of X is the prior probability of the evidence. So this is prior probability of proposition and this is prior probability of evidence. and P of C given X. It is called as posterior probability. Whereas P of X given C is the likelihood. So it has so this equation was for a single predictor variable, but in real world applications there are more than one predictor variables, and also for a classification problem there is more than one output class. So classes can be represented as, you have to represent classes C1, C2, and so on, Ck, whereas predictor variables, they can be represented as X1, X2, and so on, Xn. So the objective of a naive-Bayes algorithm is to measure conditional probability of an event with a feature vector X1, X2, and so on, Xn, belonging to a particular class Ci. Let us see the example for Bayes theorem. So we are taking game prediction using Bayes theorem. So our task is to predict the future of playing with the weather data. So here we have our data which comprises of day, outlook, humidity, wind conditions, and the final column being play. So which we have to predict. So first, let us create a frequency table using each attribute of the data set. So here we are creating frequency table for attributes outlook, humidity, and wind. So check this table. Outlook is, so we have three cases here. One is sunny, overcast, and rainy. So sunny, yes. So how many combinations we have? Sunny is 1, 2, only 2. So this is not 3, this is 2. Next, sunny, no. 1, 2, 3. So here it is 3. Next, overcast, yes combinations. Overcast, yes, 1, 2, 3, and 4. So we got 4. Whereas overcast, no, we are not having anything. So this is 0. Rainy, yes. Rainy, yes, 1, 2, 3. So rainy, yes is 3. Rainy, no. Rainy, no is 1. And the last one, 2. So this is 2. Similarly, calculate for humidity and wind also. Humidity high. So we are taking high conditions. High, yes, 1. So let me erase this. So we are done with the first part, that is outlook. Humidity high S. High S1, 2, high S3. So we got 3. High no. High no, 1, 2, 3, and 4. So this is 4. Next, normal, yes. 1, 2, 3, 4, 5, 6. Normal yes condition is 6. Normal no is only 1. So we got this table also. Next, do the same for the third one. Calculate for wind strong. Wind strong and weak. So wind strong is 1, 2, 3. Anywhere else? Strong, yes. 1, 2, 3. This is only 3. Strong, no. 1, 2, and 3. Strong, no is 3. Wind weak, yes. Weak, yes is 1, 2, 3, 4, 5, 6. This is 6. Weak, no. Weak, no is 1, 2. Yeah, it was given in reverse. Okay, this is strong and this is weak. Okay, fine. After calculating this, now we need to calculate likelihood table. So let us go to that table. So here you can see the likelihood, how we generated. So we got earlier it is sunny S combinations are 2 and total, calculate the total here, 4 plus 2 plus 3, 9. So divided by 9. Similarly, overcast is 4 and divide this by this total, that is 9. 3 by 9. Do the same for no also. No is 3 plus 2, that is 5. So 3 by 5, 0 by 5 and 2 by 5. So we got these. And calculate row wise addition. So 2 plus 3, 5. 5 by 9 plus 5 is 14. Here it is 4 by 14. And here it is 5 by 14. So row wise sum. After this, calculate P of x given C. That is sunny given S. So we are calculating for sunny now. So for that, sunny given S is this value, that is 2 by 9. Next, take P of x, that is P of sunny. So P of sunny means this value, row wise sum, which gives you 5 by 14. Next, P of C, P of S. So you need to take this value, 9 by 14. So that gives you 0.64. In the same way, you need to calculate for no also. So probability of S given no. S given no is, so this is how we calculated probability of S given sunny. So we got it as 0.39. So multiply all these values and divide it by P of sunny. Do the same thing for no. So calculate P of no given sunny. Which is equal to probability of sunny given no. Sunny given no is this one, 3 by 5, which is 0.6, into probability of no. Probability of no is this one. 5 by 14 is 0.35 divided by P of sunny. P of sunny is 0.36. So we got these two values now. So now calculate likelihood table for humidity and wind also. So you'll get these values. Okay. So do the, you use the apply the same procedure which we applied for the previous one. After getting these values, the given question is, suppose we have a day with the following values. Outlook equal to rain, humidity equal to high, wind equal to weak. You need to check whether a person can play or not under these conditions. So predict whether we can play on that day or not. So for that, chances for playing, that is likelihood of yes on that day equal to, calculate this. So outlook equal to rain given S, outlook equal to, sorry, humidity equal to high. So we are taking likelihood of yes. So all the values should be S only. Probability of wind equal to V given S, multiply that by probability of yes. So just substitute the values which we calculated before. So outlook equal to rain given S. So what is that? Outlook equal to rain given S. That value is 3 by 9. So this is 3 by 9. Similarly, probability of humidity equal to high given S is 3 by 9. Probability of wind equal to V given S. V given S is 6 by 9. And probability of yes. So out of 14 observations, we got 9. So probability of yes is 9 by 14. So if you multiply that, you'll get this result. Similarly, calculate likelihood of no. So no value is outlook equal to this one. So substitute values, we got 0.0166. So here probability of yes equal to 0.0422 divided by 0.0422 plus 0.0166. So add these two values, this one and this one. So calculate the result. So this is 0.0588. Which gives you 0.71. So after normalization, probability for S is 0.71. Calculate for the other one also. This is 0.0166. Why? This sum. So that sum is 0.0588. This is 0.29. So here our model predicts that there is 71% chance that there will be a game tomorrow. So this is how we can predict whether we can play on that day or not.